Hey, welcome. So I'm going to go over some tutorials on beginning to get started with R. So this is going to be mostly introduction to R. And this is mostly geared for people who have very low experience in R. And so we'll go over a lot of the basics of getting code to run, getting R installed, etc. I'll also be going through a lot of the data types and structures. And some of these concepts you might have somewhat learned along the way, especially if you've taken R mostly through like a stats department. But hopefully there is still some information there to hopefully clarify some stuff you might not have learned yet. So just to start off, so I just want to give you just a brief beginning on like what is R. So R is this programming language that's very common to run statistical analyses in. And so it was originally developed in the 70s. And this in the bottom right corner is actually the original kind of jotted notes of what R we wanted with R. And so R was originally, from the beginning of it, was intended to be this interactive environment for data analysis. And it was supposed to basically allow people who were not as computationally inclined to be able to start to analyze some of their data and have in the background all the Fortran and all the really old code run while they can actually focus on the stats. And so S has been around for a while. There then became a commercial version of it called S Plus. And through that, professors at University of Auckland decided to take kind of the S Plus, which was a commercial software, and create their own version called R. And this was mostly just to use it as like a teaching platform for other students to learn a lot of stuff about statistics in R. And so this is going on in the early 90s, really. And early on too, during that time was the rise of kind of this movement for open source software. And they were convinced early on to actually use the GNU public license. And so this allowed R not only to be available free to anybody who downloads it, but it also allows you to actually see the source code of what's actually going on. And this is really important that it had this kind of, from the beginning, it was also just open source. And because it allowed for it to kind of grow, especially in academic circles, for people who no longer wanted to pay for really expensive stats programs like your SPSS, SAS, et cetera, or even Stata. And so it kind of like, it first appeared around 2000. And since I would say about 2008, it's really taken off. And it's become quite common, especially in the sciences. So that's kind of where how it began. And so for today, I just want to kind of go over first how to install R, how to install R Studio, and I'll talk about what that is. I'll kind of walk you through the R Studio environment. Then I'll kind of dive into data types and structures, what they are, how to work with them, etc. And then we'll talk about loading packages at the end, and then a little bit on importing data, which I left off the outline. So first, if you don't have R installed at all, you can just go to the link r-project.org. If you click this, it'll take you to this R project for statistical computing website. And so this is run out of CRAN. And so CRAN is kind of this committee that updates R often, and it's kind of behind some of the, it runs like this, I think it's they run like the R Foundation. There's members and you can donate, etc. So if you go to this website, you can download the latest version of R. If you click here to download, they'll take you to this website where you can download to any mirror you like. So you can download from all these places. You can just go down and say, okay, download it from Bulgaria. Doesn't matter where it's at. And then from here, then you can click depending on what kind of computer you have, Linux, Mac, or Windows. So if you click those, it should pull up a window here. And you should be able to just download the latest version here, like R packages here. And it should then download automatically. Yeah. just click this link here. It'll download. And message me in Slack or email me if you have any questions or stuff isn't loading properly. It should just pull up a window and you just kind of click through it. It should install. Next, going back to here. So once you have R properly installed, that's great. And then we'll then install RStudio, which is kind of the environment the vast majority of people use to work with R. You can, in theory, just run R based off that download, but virtually no one does that anymore because it's really clunky. There's a lot of nice features in RStudio. So if you click this link to RStudio, it'll open up the website. So RStudio is a company that creates this interface that we will use. They also they've hired, and a lot of the people are really prominent in R have gone to work for them. And so they actually develop and maintain a lot of packages that are really common in R. So if you've ever used ggplot is maintained by people at RStudio in all the tidyverse, which we'll talk about more in the next lecture. So if you go here, I believe you can click download, and it'll say download. We have to choose the version. So they offer like expensive versions for like companies. There's no need for any of that. You just download the free version. It's a nice thing about R. Everything is mostly free, or virtually everything. And so here you can just click this link for download for Mac. I believe it will pull up whatever kind of operating system you have. If not, there's also the EXEs down here for Windows, etc. So click through all those, and then you should have it all downloaded. And then once you have it downloaded, we can open up RStudio. So you just kind of go click the button for RStudio. I already have it open. And so when you open RStudio, it looks something like this. So RStudio is just this kind of really helpful interactive environment to help you code. And so what you have are these 4 areas called panels. And so this first panel is where you're mostly going to be writing your code. And so you can save it and just have this as a script that you can send to someone else to run if they wanted to get the same output as you. And so this is where you'd be writing lines. If you enter more, it'll create more lines for you. Down here is the console. So when you run something up here, the output will come down here, but you can also run commands on this command line here in the console. It's generally not advised to do that because you usually want to keep a record of what you're running. So you can have it either be reproducible by someone else, or you can just keep track of what you did. But for quick things, sometimes it's nice to just run things on the console. And then if you move over here, you can see this window here is called the environment. So when we create objects or just things in R, they'll populate in this window, and it'll give us a lot of cool information about it. You can also click here to see commands and stuff you ran in the past. So for whatever reason you want to go back. And later we'll probably talk about Git, and this is also where you can connect to Git. Down here below, this might look a little differently for you depending if you set up a project or not, but I created a project, and I'll show you in a second what that means. And so this is the files in the current directory that I'm in. So, and this is like my current directory, masters, that's my folder, or Dropbox, masters_program, TA, stakeholders. And so this is all the files that are present in there. This is where you can view your plots. So when you create a plot, this will automatically open, like it'll click over to this tab, but this is where you can see them. You can also switch which plots you have, export them. And here where packages, which we'll talk about later, you can see what packages you have available. You can install them clicking this button really easily. Pull up Crayon. Here's like the screen for the help documentation. So if you ever run, I'll show you in a second how to, but if you want to pull up the documentation, it'll pull up in that tab. And viewer is for fancier stuff. If you have some kind of, say, 3D objects or other, it could be viewed there. So this is kind of like the overview of how R works. And so if I would recommend too, before we get started and before you start saving stuff, I would recommend create a project. That's usually the best way to organize everything in R. So what a project is basically, it's file r.proj, I believe. And typically what you do is, let me see, so new project. If you click this link, we don't want to save whatever I have here. You can either create one in a directory or existing directory, and you click this, it will say project, and you can name your directory name. So the idea for a project is that the project is kind of going to be the hub of all the scripts for this one specific project you're doing, where all like your scripts, all of your data and everything's organized. And so typically within your folder, understand I didn't do it yet, but I will in the future. I would have, say, here it is, the r.project. So this is my project one. When you ever opening R, you'd click this, but within this kind of folder, I would have like, say, another folder where all my raw data is organized for me to pull. I would have, say, another folder where it'd be like my clean data, that's like the exports of my scripts. I would have, say, another folder where it's all of my scripts I could pull from. And so it allows you to put everything together in one kind of organized system, so that then you have everything together. And it's not like you're just reading in data from other places. And basically so like in 6 months, when you come back to this project, things are still recognizable to you, even though you probably don't remember exactly step by step what you did 6 months ago. At least the code and everything will tell you what you did then. So I would generally advise that you just kind of can click this link, and then you can create projects. And so I already did that. So let me just open up one of the scripts I have, and we'll get going. So here's just if you have a script, it'll be a .r file, but you can also just start writing this tab or fill in a new R script here. But what I will do is just open this up, and we'll get started. So by convention in like all programming languages, everyone makes you do basic math calculations first to show you how how programming languages work. So I'll just kind of show you. So R, like everything else, can do kind of your algebraic math. So if you have a star, right, it's going to be multiplication. And so if I run this line where it says 2 times 6, right, it'll export, or say down here 12. And to run a line of code, you can either hit this thing here, where it says run, and I'll just run it for you. Here's the output. What I generally do is I follow the command it gives you on here. So it says command enter on Macs. I don't remember what it would be for Windows, but it's probably like option or control and then enter instead of the command button. But it should say if you hover your mouse over it. So you can just highlight it. I'm going to hit command enter. I'll run it again. And then you can see output down here. One nice trick to keep in mind is you can always, if you want to rerun the same line you just ran, you can hit the up arrow key. If you hit the up arrow, it'll bring back the thing you just ran. You can hit enter down here. So enter on the console command line will then actually run the line too. So you can do any kind of math, and you can also copy and paste it down here, or just highlight and run it. I don't know. You can square something. You can divide by something, etc. Any kind of simple math will follow those simple rules. So that's kind of just running stuff in R really quickly. Probably the next thing you probably want to know is what if I wanted to save this value to like retrieve it later, whatever the output of the whatever operations you're doing. So say you wanted this saved in something called results. You can do that by using this thing called the assignment arrow. And what the assignment arrow does is it takes whatever is to the right of this and then assigns it to this object called results. And then once we run this, we'll get a new thing here over in our global environment that will be called results, and it'll tell us kind of some metadata about it. But you'll also see down here, it will not give us any output on what results is, but we'll know that it's been created because of we'll see the line where result has been assigned. So run this down here. You can see, right, populated here, result's been created as a variable or an object. And it's going to be whatever 34 minus 100 is. If you wanted to recall what result is, you can just write result down here and it'll tell you. If you come from other programming languages, you can also use the print function. Either of them works fine for R. So that's kind of just the basics on getting started in R. Now I'm going to jump back to the PowerPoint and get into more details on data types. So data in R is kind of interpreted in broadly these 4 kind of categories. So data is usually any kind of values in R is either numeric, so numeric being like an integer, like this top 130, or some kind of non-integer or with a floating point. In R, we refer to these as doubles. So integer and doubles are numeric values. So those are typical numbers. If you have some kind of string of text or any kind of just characters, it is a character. And you denote that by the quotation marks around it. So this is just one string here, string of text. Here's another string, just dog. And so this is just interpreted just as text, as character. You can also have true or false kind of data. So true or false is going to be an all uppercase true or all uppercase false. Additionally, it can just be the letter T or the letter F. And so that's just interpreted as a logical data. And then finally, it gets more complicated, but there also will be factors. And I'll talk about factors a little bit more in a bit, but factors are really common for when you're building statistical models. And so factors are going to be these things that look like strings, but they're not actually strings of text. We'll say small, large, and it'll basically encode it so that if you have small again and again, it'll assign a number to it. And then if you have large, it'll assign a different number, say 2 to it. And so this is really helpful for when we're building like linear models, etc. And a huge problem people have is they have character data. They need to be factors for the models, or oftentimes people have factors when they want characters. But we'll talk about kind of changing data types in a second. So let's just jump back to R. Can I go over these? And so the next probably major, so I'll just kind of go over how you can tell what the data types are. You can figure most of them out by this function called type of. And so in R, functions basically work where it's the name of it, so type of, and then you put in between 2 parentheses the argument of what you want to run for that. So if I do type of and I plug in 30 within it, we'll see what kind of data type it is. It's a double, so that's what it outputs here. If we did true, same thing, it'll tell us logical. Here's that string again, tell us character. If you say put a number in and put quotations around it, it's no longer going to be numeric, but now it's going to actually be a character. And then if you say take the output we did earlier, if result, we can run that and check it's still double. And so here's an example of like how in R, you can kind of build these nesting operations where while R will interpret it, it'll first run this first function. So it's going to say, it's going to create a factor with just this string of text large. So if we just run this initially, I can show you what it looks like. It'll just create a factor with one level called large. One level, large. And then type of will then tell us the data type of this. Since I made it into a factor, it's going to come back as integer. And we'll kind of talk about what that means later, because that's key. But it's, we did class. We can also check it. Maybe, oh, let's say character. Never mind about that. But yeah, that's how you create a factor. And so what if you had something like this, that 300, and you're like, wait a minute, I wanted it saved as, I wanted to save this as something else. I wanted to save it as numeric. You can also run the line as dot numeric. So the as means we're changing the form, dot and then to what we're changing it to. And this will actually change it to numeric. So if I put type of around it, it will tell me now it's numeric. Yeah, or double. So you can do this for any of them. So characters is the most general form. So like the most specific is like it's like it'll go logical to numeric and then to string or characters. But you can say changing them. So, or you can try to change between some of them. So say you have logical and you wanted to do the number 1. So ones and zeros can be converted into logic. So 1 would be true. Same 0 would be false. You tried to put in, say, you tried to put in some random text, it's not gonna, I'll say NA. It won't be able to convert that into true or false. Okay, so that's just the basic on data types. It's important to know these because this is really important for when you're building up other structures. These are the types of units within what we'll talk about right now as vectors. But knowing numeric, characters, logical, and factors is super important. So it's not probably been too exciting just to go over data types. You might be wondering, how do you actually work with lots of data together? And to build up from that, we're going to now talk about vectors. So and vectors are kind of the basic units we use to build all the different kind of structures we have in R. And so how vectors work is you can create them really easily by using this command C. And so this is kind of a visualization. I'm trying to make it a little simpler. The C is called combine or concatenate, and it allows you to put in a few numbers and it'll create a vector or kind of this simple kind of structure with a bunch of numbers you can access via an index. So it's kind of like a short array. And so the first number I put in here is 2. To get the next number, you'll have a comma in between them. No, sorry, I put all of them as 2. It's just 5 2s. But in between them, you see there's commas separating them. And then at the very end, you put another parentheses at the end to close it. And that will create you a vector. We'll assign it to the letter X. And so we'll have a new object called X in our environment. And so when you do this, each of these is in a specific position within that vector. And so so this is called like the index. So this is in like this is the first element in the vector, second, third, fourth, fifth. So we can use that kind of information to subset specific values out of that vector. And so let's jump back to R and kind of go over different vectors. The other really important thing to realize with vectors is within one vector, it has to be all the same data type. So you can't have a mix of characters and logic. R won't allow that. And what R will actually do is figure out this, it'll simplify it by kind of taking, say, your logic and converting it into characters. So kind of go down to whatever is shared among them. And so let's jump back to R and I'll show you creating some vectors. So you can create numeric vectors, you can create character vectors, you can create logical vectors, you can create factor vectors. So first, you can just throw in a bunch of numbers here. So remember, C, combine or concatenate. Here are the bunch of numbers we're creating. We're going to save it to the object name numbers. And so if we just run numbers here, you can see here's our one vector, 1, 2, 3, 4, 5, or 1, 2, 3, 2, 3, 1, 4 is here too. And you can print it too, which will do the same thing I just did. Right, you can also do character vector. So you can save it. This is a bunch of dogs I know, Marlowe, June, and Bubbles. And if you write this to file, you can access it too. It says that. And so if you wanted to figure out what kind of data you have, you can run class, tell you it's character. Class or numbers will tell you numeric. Same thing you could run. Put in true, false. So it should tell me And say if you forget, if you put an extra comma in there like I just did, it's going to say, wait a minute, where's the argument 3? It's empty. And so when I fix it, it's going to now tell me logical because I put true or false in there. So as I mentioned before, it has to be all the same data type. If you try mixing it up, R will not be happy and will actually change what you've inputted to make it consistent. So say we put in numbers 1 and 2 and then the character text. If you run this mix, you will find then they'll all become all become characters. So so characters is like the broadest form. This is called coercing. It'll coerce it down to that. If you had numbers and true or false, what would it do? So logic and true or false, it'll convert these to numbers. So true will end up becoming 1, so these will be 0s. So it didn't convert courses all the way down to characters because it didn't have a need to, but now they're all numeric. And so if you did this where it's numbers, logic, and characters, it's now going to make all of these into characters. True bubbles 3.4. And same thing here. Oh, this is copied. Okay, so often this is a problem a lot of people run into is with factors. And so I just kind of want to talk about, so say you created this vector with, or say you were trying to read in this numeric vector, but it read it in as a factor instead. And so usually people look at this and they'll say, okay, look, this is being read in as a factor. We can tell because we can look at the class. It says factor. You can also run this command is dot, and that'll just tell you if it's a factor and give you true or false if it is, true since it is. So we have this factor, right? We want to create numeric. And so as we can use those like as dot commands before to change actual now vectors into different kind of classes or data types. And so what most people think is, okay, so this is read as a factor, we want numeric. And this is a very common problem, especially with importing data. And so people sort of go, okay, let me try s.numeric and then plug in the vector. Just plug in the whole thing in here. And when they run this, they get values like 3, 5, 3, 4, 2, 1. They'll go back and be like, wait a minute, this does not match up what I have in here. What is happening here? Why is that happening? And so the reason why that's happening is it's actually pulling those are the levels from it. And so it'll organize them. So 1 ends up being the lowest level. You can see here, level 1. And so when it's 2, it's the second level, and then 2.5. So that's where that 3 comes from. It's the third level within that set. The 4 is the last level, right? So 5, etc. So that's really confusing. And so if you ever run into this problem, the solution to it is to first convert it into characters. So it's the most general data type. And so now you can see these are all characters. And once you do that, you can then plug it in as a numeric and then give you the actual values you want. So if you ever have factors, you need to convert them to numeric, do as.character first, and then do as.numeric after that to create the vector you wanted. Okay, now let's get into subsetting data. So this is where the index comes into play. And so here's how you subset vectors in R. Let me just make this one. I don't know if you'll see that or not. So imagine we created this vector here. These are 3 elements within it. Just imagine these are all numbers or characters or whatever. And we're assigning it to this object called X. So subsetting is this way where we can use the information, the indices or the index of each of them to pull out specific values or sets of values from that vector we want. And so we do this by using the bracket notation. So if you have your object, right after that, if you put brackets and then you plug in some kind of number, it will then give you whatever index it is back. So if you plug in just a 1, it'll give you the first index. We change this to a 2, give us this 1. Change that to a 3, it would have given us that third one. and only that one because we just have that 3. And you can get much more complicated with indexing and pulling out, subsetting vectors. So one thing you can do is you can also use these colons. And this will say 2 through 3, which in this example is not too exciting because there's no numbers in between 2 and 3. But imagine this is a vector, say, of like 100. You could do like 50 to 7 or 50 colon 70, and it'll pull all the numbers from 50, all the numbers that are located in the index between 50 and 70. So that's really powerful. You can pull out a fair amount of data that way. Say you knew exactly which indices you wanted, you can actually plug in another vector within that, and this vector is just pulling out the indices you want. So it's saying 1 and 3. So you pull this 2 out. You can also, for all of them, use minus or negative values for each of the indices. And in R, these will actually remove these when it outputs it. So it's going to say anything that doesn't fit these 2. We'll give you just this middle one because that's 2, and 2 would be, and 2 hasn't been excluded. So let's jump back to R. So going back to that numbers vector that I created earlier, if we pull out the first one, we can just use that first bracket like that. We wanted to pull out the third index. I just put a 3rd in there. It's going to go 1, 2, 3. Pull out this 3. Oops. And then give this that. If you want the 4th one, 4th, etc., which is a 2. You put in something here that's not the right size. So say like tell the size of your vector, you use this command called length. So if 7 kind of, so you can, knowing that you can use an index 1 through 7. But say like I was like not paying attention and I plugged in 10 or 11. If you did that, it's going to say NA because that doesn't exist. In data frames we'll talk about later, I think you should say subscript is out of bounds. So that usually means that index is not there. One more thing I haven't mentioned yet, but I think might be really helpful is whenever you start writing something, R will kind of tell you, will give you the options you can just pull from. And since I have an object called numbers, it just told me here's numbers. And if you hit tab, it'll actually tab complete and fill in all the rest of the letters. Tab completing is really helpful because then you are less likely to make spelling errors, etc. So, and it makes it much quicker to write. So, yeah. So here's the use of the colon 1 through 3. We can also set it to anything like 1 through 5. So it pulls out the index 1 through 5. Right, you can supply a vector as we mentioned earlier. Give us 1, 4, and 5. So it's like 1, 4, and 5 here. Gives us these values. And then negative values will exclude it from the index. Cool. So that's just basic subsetting. It's really helpful to know that for later. And now we'll get into some of the data forms. So data frames and matrices. Let's go back to PowerPoint and show you what those are. So understanding vectors is really important because it's just like the basic building block for a lot of these more complex data structures that you'll be using. The most common data structures are the matrix and the data frame. And so these are kind of built up as when you are supplying lots or multiple vectors or more vectors, you can then create these structures pretty easily. And so a matrix is going to basically be it's a structure where you have X number of rows, and rows go across and columns go up and down. And through all of these, each of these have to all be the same data type. So it's like a matrix of all numeric. It could be a matrix of all logic. It could be characters too, I believe. It has to be all homogeneous and it's 2-dimensional here. Most of the time though, you have data that's probably going to be heterogeneous. In other words, you have vectors at differing data types. So imagine the blue is like characters, this could be logical, this could be numeric, etc. And so what the power of the data frame is that similar to matrix, it has rows and columns, but now the power is that you can have all these different types of data within one form. And this is most intuitive for like when you're inputting data into Excel. This is kind of what you're usually thinking about. And the power too is that now that you have these rows, you can extract these rows really easily, and you can kind of relate values from one vector to another by the row number as well. So vast majority of stuff we'll talk about is data frames. And the last one I'll talk about really, because arrays are extremely common, especially in more data analysis courses. I think if you do modeling, it could come up. So we're not going to really talk about them, but arrays allow you to get like as many dimensions as you want. And they're homogeneous, like matrix. But anyways, a list is the other most common form. It's the most flexible of them all. It allows you to put in any kind of size. So you can have a vectors, lots of vectors. You can have a matrix. You can have other vectors or a data frame all in one. And then they're kind of indexed this way, where this is the first one, second, third, etc. And this actually is really complicated, but this is, you can have lists within lists. So this is technically the first list within this. This is the second. This is one object. Lists get to be really complicated, but if you kind of know what you're working with, it can actually be a very coherent way to keep track of all your data. The only other thing I'll mention is that with data frames and matrices, you have to have the same number of rows for each of the, or sorry, you have the same number of elements for each of these vectors to create them. So really all a data frame and matrix is that they're just a bunch of vectors that have been placed or kind of glued next to each other so that now you have some kind of row information. So if one's like a different length, you'll get an error when you're creating a data frame. If you're reading in stuff from Excel to create a data frame into R, they'll usually populate some of those columns with NAs so that they're all the same length. So that's data structures broadly. Most common, probably data frame for vast majority of stuff you'll do. Just moving on a bit to subsetting. So subsetting data and data frames and matrices is done the exact same way. And now because you have not only, now since you're moving beyond vectors that were one dimension, now we have 2 dimensions, you need to have a row and column for your subsetting. So we're still using the bracket. So dat is this data frame here. And so the first thing in all of them is your row. And then the second element is always, or second part be after the comma will be your column. So this is saying extract the data that's in row 1 and also in column 3. So it's just that cell here. Same as, and then same as before, colons can also be used. If you leave, if there's nothing after or before a comma, so like this, there's nothing, there's no columns specified. That means you're selecting all of the columns there. So 2:3 means rows 2 and 3 and all of the columns here. Same thing before, the minus signs work or negative values work here. And you can also input vectors as well to pull out specific stuff. Just jump back to R, talk about some examples. So let's go through some data or structures. So to create a data frame, it's just this object called data.frame. And then since I was saying before, vectors are the building blocks, you just supply the vectors to create it. So first our vector here is just dog names. I think it's the same we used before. And then I created another vector called size, which is just numeric values. Good with strangers is logical, true or false that they are. So if you can write all of this. And another thing to mention, in between each of these vectors, they're separated by a comma. By convention, just to make it easier to read, I put all of these different vectors on their own line. And then this kind of seals it here. So this closes that. One really nice thing too about R is, or what gets tricky about R is you always have a bunch of parentheses to close. And so RStudio, if you kind of click and go beyond it, it'll tell you which one this closes with. So I can make sure this vector is closing properly. This is closing here properly. And this one closes on the outside of it. So if I run all this together, create a data frame called dog.df. And if I run this, you'll see the structure here. And so the first one becomes your first column, second column is size, and third will be good with strangers. And so here, you can see the 3 columns. Now this is all being created as one row. So now we know that Marlowe is not only a dog name, but it's a size 100 and is good with strangers, very good with strangers. Whereas my dog, June, slightly smaller, 80, whatever units, but it's not good with strangers. She gets very scared. So that's how you create a data frame. And if you're on class, you can just see, let's say, so we see created a data frame. So just to save time, I just created values. So I plugged in just a bunch of random numbers to create a matrix below here. So this is a function to create a matrix. This command runif, commonly just referred to as runif, because it's one of those examples where you just kind of see the first few letters and you think it's a word, but it's pulling uniform numbers from whatever you specify. If you hover over it, it'll actually give you what the different commands are. So the first command I'm plugging in is in, and that's the number min equals the lowest number, max is the top number. So it's basically the same for numbers between 0 and 100. Randomly draw 25 of them. So if you run this, just create a bunch of random numbers. And then I'm just specifying the number of rows and columns. So it's going to be a 5 by 5 matrix. And if you run this all, well, here's your matrix. And the nice thing too is like when you see this matrix actually tells you the structure too. So if you wanted to pull that first column, right? So here's the code for it. Here's the code for the first row, etc. So it helps to remember this. So matrix is a stricter form, right? It has to all be the same data type. Data frames are more flexible, where each of the columns have to be the same data type, but the columns can differ among each other. And so kind of like building up from before, it'll be really easy to create a matrix into a data frame because they can all be the same data type within a matrix as well. So if you run as.dataframe, which just takes that, creates a data frame, it'll create it. It'll add in these V's as, these V's are just kind of placeholders for the names of the data frame since there weren't any specified. But imagine if we took the dog data frame, we're going to have the same issue where it's going to have to coerce it to all the same data type. And since our dog data frame had characters, numbers, logic, it's going to go all the way to characters. That's why we got that. That's why everything has quotations around it. And one other thing I wanted to mention before I moved on, within functions, sometimes you have different arguments. And within functions, we specify them with equal signs. So if I go back to, we usually specify them with equal signs within arguments. So data equals is this for data we're plugging into the matrix, and the number of rows, number of columns is equal 5 or 5 there. So that's just convention for writing code in R. Cool. Just some quick subsetting too to show you how it works. So this is going to pull row 2, columns 1 through 4. And then since this kind of is only just, since I'm kind of pulling that one kind of array of values, this will actually just give me a vector back from it. It'll simplify it down. Whereas if I did this, it'll still give me a matrix because I have all the rows and columns 1 through 5. And so you can subset it whatever you like. Working with lists, I'm going to jump back to PowerPoint because this gets a little more complicated. So here's an example of subsetting with lists. Just want to go over it before we dive into it. So remember, lists allows you any length for any of them. Allows you the most freedom, but at the same time, it's probably the most complicated to work with. And so imagine we create this list, and where in this box, it's just, this is the whole list of A. So in your first index, you have this vector 1, 2, 3. The third, you have just this character. If there's one element, it's actually referred to as an atomic vector. So it's an atomic vector called just a string. Third, it's an atomic vector of numeric data, pi, oops. And then the last is this other string with two other atomic vectors of -1, -5. And so the subset lists, it gets to be trickier. If you pull out the first element in a second, they'll return you a list with the first vector and the atomic vector, a string. Same thing here. If you did fourth, it would return you the fourth element in the list, which is just another list within list. If you actually wanted to try to extract, say, some of the elements, say like you want to just pull this list out of that list so it's not nested within two lists, you can use what are called double brackets, and that will remove one of the layers of lists for this. So now we're just left with a list with these two atomic vectors. And if you want to keep extracting from, say, the original A object, you can then add other brackets here. This will pull out this first element. And if you do 2, then it'll actually extract the atomic vector. So I think this gets to be really complicated. Sorry, 1 second. But hopefully this example will help explain it. So imagine you have some kind of salt shaker. You have then pepper that is within packets within it. And say each of these packets a different index within your list. You pulled out the first one. You still have it within the list, right? It's still in the salt shaker. So it's not super convenient, but you have the first element. If you do double brackets, you extract it from the container. Now you just have this, which I would assume is a list within it because it's just a bunch of pepper grains. And then you can extract everything within that by using the double brackets here to get all the elements on that. So that's kind of how lists work. I'll show you briefly a little bit of subsetting the list. So we can take like the stuff we created earlier, say like dog names, we got that. Actually, I can plug in, make it even more complicated, the dog df. Let's just do that, dog df. We can pull out numbers as a random matrix we have, and then calc is this. So these are the names of the 3 different elements, which we can use the subset later. But then this will create a whole list of the whole thing, example list. And then if you run this, it'll tell you each of them. So $sign refers to just the element, which the name of it is. So the first one's dogs, second's numbers, third is calc. Common examples of lists you'll find. I think the coefficients and everything when you run linear models exports as lists. Sometimes you'll have packages that require inputs of lists to run them, especially if you're in like any kind of ODE kind of calculus kind of things. But generally you don't worry too much about them. So if, say, for example, right, if I pull the first one, it's still going to be a list, but it'll give me the dog values. And if I run this class, it'll clarify it's a list. And so you might be wondering, that's not really helpful. It's hard for me to extract stuff within there. I want to pull out just the data frame of dogs. So you put the double brackets, it'll give you that data frame. So I'll show you. Oops. R is case sensitive, so that has to be the right spelling. Say data frame. You can also name the element of it. So if I just said dogs as a character, it would also pull it out for me. Same thing here. So I can pull out, say, element 1. This code no longer works because, so I'll actually show you. So if you tried to plug in a data frame, just something that has only one, it just has only rows or only one value, it's not going to work because it needs a row and it needs rows and columns. Actually, maybe it will work. Cool. I'll just pull out the second element. Never mind. I misspoke. I think usually, let me see. I guess we can just pull out, they'll just assume it's a column. I thought it would fail. Definitely for matrices will fail on you. In general, it should just, you should still probably just specify. Oh, right, okay. So actually, one thing to keep in mind, if I run this, it's still gonna be a data frame. It's not gonna extract it. But if I run this one, it's gonna output it as a vector. So that's one main difference too. And the reason I knew this was a data frame because it gave me the 1, 2, 3 like this. This is still the structure of a data frame. So keep that in mind. Another thing I didn't mention, and most of you will probably learn it, but I generally tend to avoid doing this because you rarely need to. But you can also use the $sign to pull out columns and data frames. And that will just give you it as a vector too. But you can use it. I typically don't want to teach that first because that's like the only use of that. And it's whereas like subsetting with indices is always useful, albeit it's a little more abstract. Okay. So that is kind of my overview of different data types. Now I just kind of, oh, maybe more in the video. Let me just jump over here. Now let's kind of jump into kind of debugging and packages. And then finally, we'll talk about reading in data briefly. So R is really helpful because since R is what's considered an object-oriented language, where it's basically, you have these built-in functions called base R, which are just preloaded. They're actually from packages that are preloaded every time you launch R. So the people in CRAN have all decided these are the functions we want everyone to always have, and this is just kind of included in R. But what's nice about it is you can customize it a fair amount from there. And you can read in other functions that other people have created for specific uses. So there's millions of packages for like spatial data analysis, where someone said, it's just created it and you can read it in, and then you can pull all these cool objects to do a bunch of these analyses. And so the first thing I just want to show you is just how do you kind of load in or install these packages. So if you don't have it installed, which for the vast majority of them, unless it's included in kind of normal R and you just got R, you need to download them. And so if you want to run the line of code, it's called install.packages, and then you have to put in characters, the name of the package. If you do this, it's going to pull it from CRAN, which for the vast majority of things you want will work there. If you know there's some specific package that's only on GitHub and they haven't uploaded it to CRAN, and this is increasingly common because CRAN is a pain to work with. I mean, it has to meet all these conditions, and for a lot of people, it's a lot of time and work for people who just kind of want to just write the function. And so some people try to circumvent CRAN. Another way you'll see, and they'll usually put this on top of their code, is they'll use what's called remotes. And then I think it's GitHub pull, I believe. Yeah, you GitHub pull, and then you'll name the name like their account and then / their package. It'll typically be on their GitHub, so you just copy and paste it in, so you don't have to actually know it. But this is like the other way to pull it from GitHub. Now, you need to do this, you would need the remotes package to do it. So you would have to install that first, but that one is on CRAN. So you can easily install that. I'm not going to run install right now because it takes a lot of, especially with tidyverse, it's a lot of stuff. And so if you want to run this tidyverse as a package, we're going to use a lot in this course. So I would just already install it. Tidyverse is basically a suite of a bunch of packages in R. And this is all run by RStudio. So if you're familiar with some packages in R, you might have heard of them. It includes ggplot, includes dplyr, it includes tidyr, which helps with pivoting data, readr, I can keep going on, magrier, I think that's how you pronounce it, the piping one. It includes a bunch of these packages already, and they're all kind of in the tidyr framework. So you can install it that way. If you want to, you can also install from CRAN here, and you just type it in, and it'll give you a dropdown. So that's actually helpful, so you know you installed it correctly. For very case, you can also install it via downloaded like archived like file. Highly doubt that'll happen. And the other thing to keep in mind when you install it, it will also install what are called dependencies. So if it requires other packages to run that you don't have, they're going to install those too while you do it. And a lot of the times people have trouble installing packages. It's usually there's some issue with the dependencies. It's usually something like the version of the package you're trying to load as a dependency is not updated to the newest version of R that you're trying to run, so therefore it won't work. There's some kind of workarounds to figure that out, but let me know if you do run into any issues with that. So if you're on this line, it would install that. But once it's all installed and everything looks good, then you can use this function called library. And library will then pull up and kind of load those functions into your kind of pantheon of objects you can use. So library tidyverse, you don't need the quotations around it anymore. I think you can run it with quotations too. So I just loaded the tidyverse package into my environment. And you might be wondering, like, how do I know what it can do and stuff? Well, first you can do is you can actually just go to packages and search for it, pull it up, tidyverse. And this will read you what's called the documentation and gives you a bunch of help files. So you say like what conflicts it has. But you can go here to description, gives you some brief information. Mostly you probably want to go to user guides, where here's like the overview for the idea for the package. Let me try to see, there's usually a way to get to the objects. It says like a .index. Anyways, well, tidyverse loads a bunch of packages within your thing. So I can pull up, say, dplyr common package from it. No, you can access it this way. So when you open up dplyr, it tells you the version, gives you a description of what it is. Not super important for that, but here are all the different functions that runs from dplyr. So these are stuff you can pull from. You can read filter, something we'll talk a lot about later, and it'll give you the description of what filter does. So filtering is kind of the alternative to subsetting data frames, essentially. So it gives you what the values are, helpful information, et cetera, and lots of examples at the bottom. So at the end, I would read through, basically figure out what the arguments are, what they mean, like what do you need to put into it. And then this stuff in the middle is hugely important, but most important is kind of reading through some of these help files or examples and trying to understand them. And oops, easier way to get to that instead of just searching for stuff is you can use this question mark, and the question mark will pull up the help file. So say I wanted to look up the filter command like I did again. You do this, it'll actually pull this up. And since there's multiple things that could be called filter, because I've loaded, the stats package is automatically loaded, and there's a filter from dplyr. You have to choose which one you mean, which we probably meant dplyr, but you can also look at the stats one. And so this is actually another really important thing when you're loading packages. Whatever the last package you loaded, if there's a name of another function within your environment that's exactly the same as the one you're just loading, whatever the newest thing you've loaded, so in this case, dplyr from tidyverse, that's going to mask over, when I just run filter, over the stats version of filter, which I think is for like, doing like linear filtering. In the vast majority of cases, this is not going to be an issue with loading. Tidyverse we'll use next time. It will be a problem for some packages with some of the commands, and tidyverse will get masked over. And usually when you're loading packages, R will tell you which conflicts exist, but that can lead to problems online. So question mark gives you the all the information of that function. I think packages, right? Most people don't, but you can also pull it up that way. Another thing I didn't mention before when I was talking about remotes, do I still have that? So when I was writing this, I didn't explain this syntax at all. So you can also pull functions from other libraries that you haven't loaded, like you haven't run the library command on. And you can do this by using the double colon. So this is saying from the remotes package, use this GitHub pull object or function. And this allows you to access this kind of functionality without, say, loading in a bunch of other stuff from remotes. I use this a bunch with a bunch of some of the stat software that other like scientists write, because usually I'm only needing one or two functions from it. And usually their code can be, unfortunately, sloppy, and it'll mask over a bunch of really common objects. And so that's a way to kind of limit the kind of problems down the line from, yeah. Because like I know kind of what issues tidyverse will have, but a lot of times when I'm running someone's random package, it can be problematic just to load it in, because then you'll find like an hour later, half your code doesn't work because they masked over something. Then you have to kind of restart all of our, start over, which isn't a big deal. But. And so you can also say pull help files using the double colon. So this is the ANOVA, which allows for random effects from the car package, or sorry, let's say you do type 1, type 2, type 3 ANOVAs. Okay. So now let's just kind of go into debugging. So what if your code doesn't work and you don't know why? What can you do? So imagine you have some line of code like this. So you have some vector, you have a bunch of numbers, there's an NA, and you wanted to sum it. So the sum command takes this vector and then we'll add all of it up. So if you run this, you'll see you get an NA, which you're like, that doesn't make sense because I have numbers, I should have some kind of value. So what would I do to kind of work through this kind of problem? First thing, if I'm not super familiar with the function I'm running, pull up the help file. So we'll pull up, use the question mark for sum, pull it up, base, it's a base R function, classic function. And so you can read what it does. It's going to sum up the present values in the arguments. The dot, dot, dot means basically anything can go in there. So it's usually what you use if you want to allow someone to specify vectors or anything in there. But you also see there's this other argument called na.rm. And so it says logical. So this means that it is requiring a logical input. So it wants true or false. And then it says, should missing values, including NaN, be removed? And so as default, and you can tell this by the function, it says na.rm equals false. So it says that's default setting. If you don't specify it, it's going to assume you want the NAs in there. Since we didn't include that, that's where we got an NA, because we can't add up NAs and numbers together. So sweet. So reading a documentation led you to figure out, okay, I need to specify that this should be true instead of false. So you rerun the line of code again. Okay, sweet. Now it tells me the sum is 25, because I said na.rm equals true. You can always Google it too if you have issues. So what I would usually say is, like, we look at the issue we're having. So problem we have is we're trying to sum gives an NA. So I would say like sum gives NA R, go over to Google, just kind of do this. You can kind of see what people say. So you can go to this website called Stack Overflow, which is really helpful, and try to read what other people have run into using R, something similar to. So you find this where it says, I'm trying to sum it, but results are NA. Oh, that sounds exactly like what we have. We're trying to figure that out. And so you can read down here. Here's like a list of stuff that might be having troubles. How many elements are summing? Big number of entries R can handle. That's not a big issue for us. Not too much of a concern. Then you can see, number 4, sweet. Do you have NAs in your data? If you sum anything with NAs present, the result will be an NA, unless you handle it properly. So there you go. So you can also find the solution here. So Googling is really helpful. The important thing is just like the function you're using, kind of the problem you're having, And adding the letter R is really helpful so you don't get other programming languages too. So that's what I would say. Here's just a link, I think, to the same thing I ran into. So say you wanted to subtract two vectors. And one thing I don't think I mentioned yet, but one really cool thing about R is that it kind of vectorizes. So if you have two vectors of the same length and you subtract them, it's going to go element by element and subtract them. And that's really cool because it's a really quick way to do an operation like that. But another like interesting thing, just to show you vectorize, is like you can square it. And this will square every element within that vector. So vectorizing, super helpful. But anyways, imagine you're trying to subtract these two and there's some problem where it's not working. And one reason you can, one kind of sign that you can tell it's not working is you see this kind of X. That means something's wrong probably, but we'll try to run it and see what happens. It says error, unexpected numeric constant in this. So this shows you the line that failed. And you see that there's something wrong here, down here. And if you look here also, it tells you unexpected token 5. So it's saying there's the number 5 is what's messing this up. And so this problem is really tricky. If you have some problem like this, unexpected error constant, Googling might be really helpful. So let's see what Googling says. So I just copy the error message straight into R. And just, you would go through a bunch of these links. Stack Overflow is really great. Let's see if they have anything. This doesn't seem super helpful for what we're doing. Since I've already done this before, I know it's this GitHub link is super helpful. So someone else is having the same kind of problem. Kind of same idea, 1, 2, 3, 4, 5. That's kind of like the exact error we're having. So unexpected numeric constant means rather than understanding. Crazy Googling. So there's something wrong with the syntax. You have a typo. So what's actually happening in the code, right, is that there's a missing comma in there. And so that's why it's failing. So make sure there's comma. You can also see in R, let's zoom in. Underneath, oh no. When you have some error like that, they all kind of like in Word, they'll have the little squiggly red underline thing. And that also will show you that there's an error in it. So once I do this, it should get rid of this error. And this should work now. So it subtracts each of those element by element. Other common issues, I won't kind of go through debugging each of these, but I would say always double check parentheses. So unexpected parentheses here, kind of clues you in there's a parentheses problem. So there's an extra parentheses here. You can see this doesn't close with anything. So that's the problem there. So you remove that. So run properly. Another error, empty. So this is like the opposite. What if you forgot a parentheses? So in R, when you forget like a parentheses, typically what happens is it'll give you this plus sign. And so people tend to panic. They'll hit enter, trying to get rid of it, and then keep hitting enter. And R will keep messing with you and keep giving you more plus signs. What you can actually do is if you're like, oh, I just forgot the very last one, I forgot to copy it, you can actually just close it here, run the command, should work. And then rerun it again, just double check up here. But the other thing too is you can also run it and hit escape, and escape will close it too. And you can just run it again with the parentheses. So always check your parentheses. Sometimes you have some code that looks like this, or some problem like this where you have a bunch of the ones aren't closed. Oh, actually it'll fail. Great. I don't know if it can create one that doesn't. But sometimes you have to do multiple ones, and typically at that point, something is really wrong with your code and it's just going to error out and you'll have to figure out how to close them. Escape key will always end stuff too. Cool. And the last thing I was just going to mention, so if you're Googling is a great example, consulting online forum or someone else, you can always send, if you have a friend who's good at R, or definitely send stuff to me, especially on Slack or an email. I'll get back to you. And the main thing is like, give me what the error is, what you're trying to run. If you can supply me the script with the problem, that'd be excellent, but whatever you can give, that'd be helpful. And so consult people, Google error messages. You can always break big chunks of code down into smaller pieces and run those and make sure all those individual pieces work until the end, until you kind of find the problem. And there's other kind of more complex debugging tools, which I don't have time to get into. But if you click this link and go through this talk, Jenny and Brian does a really good job explaining them. And I would highly recommend that. So last thing I want to talk on before we wrap up for this video is reading in data. So I just want to make sure first time you're in R, you can at least get data into R, because that's super important to get you started. And so the way you read in data is using this function called read.csv, if it's a CSV file. And so R typically does not work well with just normal Excel files. So the vast majority of the time, you usually will just be wanting to import what are called CSV files, which are just comma separated values. And if you have a file open in Excel, it's really easy to export it into a CSV file. You just click the other kind of file format and it'll do it for you. It'll give you some kind of warning that you'll lose some information, especially if you have like coloring or stuff like that. Totally fine. You won't need that in R usually. So if you use this read.csv, then you write the name of the path and you put quotations around it, and then it'll read in this file. So if I just run this, if you don't assign it to anything, it's just going to output it to your console. And so here's this kind of data set we'll work on next video. You can see it read it all in. It's kind of confusing. It's hard to read because it's there. But we can assign it to a variable and open it. And so this is, if you see what we read in, we can check class. We'll see it's a data frame. And one really helpful thing in R, oops, pull up my other R. One really helpful thing is in RStudio, if you do the view command with that data frame, you can then pull it up as a tab and it'll look a lot like your Excel kind of window. So your columns, make sure everything parses correctly. You can, if it's a big data set, you can have it go to specific columns. Another nice thing is you can actually filter data really easily this way. So if you want to remove all certain columns, filtering is really helpful. It can be really slow if you have a really big data set, so I would be careful if you're using view. It can crash your R sometimes, but the vast majority of the time it should be fine. So this is the view command to open that. If you have a really big data set, I would recommend using the read from the readr package that I load in from tidyverse. This is much quicker usually. I forget the command to look at how long time is, but it's really quick. And it's also nice, it gives you like a loading window if it's really big. The other nice thing too is it outputs it in a way that's really readable. So Tibble is just like a more readable data frame essentially. And I'll also tell you how it parses each of the columns. So default, it shows most of them as doubles, but then it also has this ITS column, it's going to be characters. And below it also tells you these are doubles and these are characters. So that's really helpful. If you're unsure where your data is stored, often it's helpful to use this file.choose command within read.csv. If you run this, it will pull up a help menu and then it'll allow you to select the file from here. Cool. If you have tab separated values or a text file essentially, you can read in with the read.table. So this is just some random data I wrote here. Read.tsv will do the same exact thing. Awesome. So that is all I have for the first video. The next video will be going over more in depth and kind of the tidyverse kind of package. Typically for most of my code, if I'm doing data manipulation and stuff, all of it's through tidyverse. And then I pull in specific stat packages for the rest of it. So I'm going to do a whole video dedicated to get you up to speed on tidyverse. Let me know if you have any questions or if I misspoke, or let me know. But thank you. That's all I have so far for this video. Next video will be up soon.